Hello everyone and welcome to Live from the Lab. This is the show where we talk about different technologies that Bruker's developed to help scientists study the world around us. Today's topic is about XRD automation, and more specifically, we're excited to announce a brand new product in this episode. So we've got a big lineup today. We're going to hear from the product manager, Carsten Knorr, about the actual development of the product and some of the new features in it. We're also going to see a video that shows all of the different features and the benefits out there for automation with our new XRD solution here. And then we're going to see it live in our studio with my colleague, Nick Radesny, and talk about XRD automation, the importance of it, and actually see it working and how the software operates. So to kick things off, let's see it in action.
Thank you, John, for introducing me and allowing me to open today's webinar. Ladies and gentlemen, it's my pleasure to introduce the future of automated X-ray diffraction, the D6-phaser Autoloader. The D6-phaser Autoloader is not just another benchtop X-ray diffractometer. It's a tool that streamlines your workflow and maximizes efficiency by quickly accessing phase composition and content through automated powder diffraction. This state-of-the-art solution is the answer for quality control engineers and laboratory managers who demand the highest standards of product consistency and quality, whether it's for construction materials or pharmaceuticals. Automatic benchtop XRDs control production processes, saving energy and consumables while increasing process yields. Typical examples can be found in the cement industry as well as in the beneficiation of ores and the production of metals. In terms of materials innovation, it's the ideal tool for big data initiatives, research into new energy storage materials, or the search for new formulations in the pharmaceutical industry. Its fast and reliable measurements make it the perfect choice. The new device is the result of a marriage between the well-established powder diffraction capabilities of the D6-phaser and the operational convenience and consistency of the new Autoloader. In terms of benchtop diffraction capabilities, I will just highlight the 1.2 kilowatt source power for maximum sample throughput, dynamic beam optimization for best peak-to-background data, the Lynxeye family of detectors for highest efficiency, and the goniometer's 0.01 degree accuracy. I'm going to give you a quick overview of the key features of the Autoloader. It uses industry-standard-sized specimen rings. This ensures sample preparation consistency through compatibility with automated powder milling and pressing devices. The Autoloader can be operated manually, or samples can be provided via a conveyor belt. Up to 5 magazine positions allow for the automation of loading and unloading of samples, while also storing reference samples for continued operation and performance qualification. A manual loading position allows for the quick introduction of priority samples, while preloading of the process samples makes the most of the instrument's uptime and shortens sample turnaround. The new device is fully integrated with our Diffract.suite software, offering unparalleled automation in sample handling, measurement, data evaluation, and results reporting. The system is simple to operate. You can run it in single-click push-button mode or integrate the unit into an online autonomous laboratory environment. Our automated applications span the full range from positive materials identification to degree of crystallinity, to phase composition of crystalline and amorphous materials, crystallite size, lattice parameters, and more. Our EVA, DQuant, and Topaz software is your analytical solution. With pattern matching, calibrations, partial least squares regression, semi-quantitative and Rietveld-based methods at its core, it keeps your analytical needs covered at any time, without the need for extended operator training. The D6 Phaser Autoloader is the benchtop solution for streamlining sample handling. The AXS-COM protocol ensures complete compatibility and seamless integration with other Bruker diffraction or elemental analyzers and third-party sample preparation and transport systems. The D6 Phaser Autoloader is not just another benchtop X-ray diffractometer. It streamlines your workflow, enhances product and operator safety, and maximizes efficiency. The Autoloader provides consistency in sample preparation, measurement consistency, and results consistency. We are excited to bring this innovation to you and to explore the future of automated XRD together. I'll leave it with John and the medicine team for further details. Thank you for joining us today.
Welcome to the studio. So here I am joined by Nick Kordesny.
Good morning, John. Happy to be here.
And also our newest product, the D6 Phaser Autoloader. So thanks to Karsten for giving us that overview of the new product. So that's really exciting. And we are really happy to be showcasing this new automation solution. So speaking of automation, Nick, why is automation important for X-ray diffraction?
Yeah, that's a good question. So really automation is important when you really need consistency. That's really the key to automating your analysis. There's a lot of variables that you might run into when you have humans doing things. So if you can remove some of those, then you can get more consistent results for whatever you're analyzing. And
I know next week you've actually got a class that you'll be teaching, and one of the big topics there is always sample prep, right? That's right. Sample prep, you might start with the same powder as everybody else, but you might prep it differently, and depending on how you prepare your powder, that can have a pretty big impact on the results that you see. So before that sample ever even comes to the system, to the D6 Phaser Autoloader in this case, we're going to have to do some sort of sample prep, and part of that depends on which model you'd get, whether it's this version, which is the 5 position. So if we take off the cover. Yep. Let's take a look. There we go. So what do we have? We have 5 positions, is that? So this D6 Phaser Autoloader has 5 positions, and they're all externally loaded, so you can load and unload samples while a measurement is running. No need to turn off the X-rays or open the door. So there is a special little rotating carousel on the inside of it that allows that sample exchange without any sort of danger. Exactly. It's all radiation safe. Yeah. So this particular system, like we said, there's 5 samples, and then you also have a manual load position. Correct. So 6 total if you include the manual load position. The other option is to load and unload samples via conveyor belt. Okay, so how would that look if we look again at this? Yeah, so if we take a look at the front of the D6 Phaser Autoloader, you'll see that the position here on the left is actually removable. So if you were to configure this with a conveyor belt, this part would come off, and the conveyor belt would load the sample in from the left side here. All right, just like we saw in the video. Exactly. So now, of course, if you're ordering it, then you would order it with the right, setup right from our factory, and yep, the conveyor belt is completely optional. You could keep it with just the 5 positions we see here, or you could add a conveyor belt later. So Now, in terms of prepping a sample, like in that automation environment for cement or something like that, what are some of those like really important things that you would recommend to people that they think about during that sample prep?
Again, it all comes down to consistency. So there are options for automated sample prep. There are these larger machines that you can pour in your powder and it will mill it down to a really fine particle size and press it into a ring for you. And since a machine is doing it, it's the same every single time.
All right, and those are available. Typically, those systems can be in 2 different sizes, right? 51.5 or...
Right, there's 2 industry sizes. There's the 51.5 millimeter sample holders, like we're going to see today. But then there's the one that's slightly smaller, a 40 millimeter sample ring.
All right, and sometimes those actually are just rings. They look like a donut, and sample just gets pressed in.
Exactly.
Now, you had mentioned that consistency is important, and one thing I think that sometimes people overlook is that it's more important to be consistent on that sample prep than it is to be perfect.
Right, exactly. So on that topic, we think about preferred orientation with our powders. So usually when we're preparing our samples, we say, you don't want to press too hard on the powder because you might induce some preferred orientation. But again, it's all about consistency in automation. So with those automated sample prep machines, even though you're pressing on it, it's pressing the exact same amount. So you're getting that consistency from one sample to the next.
Now, another hot topic that we've started to see out there, in addition to industrial automation, is actually R&D automation. And there, what we're talking about is machines that actually will make a sample. It could be a thin film deposition tool. It could be a complex chemical reactor that's creating the sample. Then it measures it here, measures it on other instruments, uses that data and, along with learning algorithms and some AI in order to customize materials. That's something that's really hot right now in the battery market. So when you think about automation, don't just think about these classic industrial cement cases. Also think, the future of the lab and what that looks like. So now, in terms of the software integration then, so we talked about a conveyor, but we also then have to have some sort of software that's driving that system.
Yeah, exactly. So we have some software called AXSCOM, and what AXSCOM does is it facilitates the movement of a sample from maybe different instruments along a conveyor belt or robotic arm, from one instrument to another, and also the analysis as well. And
the AXSCOM is an industry standard software, I'd call it. I mean,
right.
It's compatible with everything, and everything is compatible with it.
Right, not just our Bruker software. It also is compatible with some other platforms out there as well.
So if you have a LIMS database, it'll drop those results right in there, allow the control, and you're good to go. Now, if you are using, though, the system like this, where we're relying more on the manual automation, now in this case, the sample prep, that would look a little different, but it has the same steps, right? You're still going to want to have some consistency in that prep.
Exactly. So you might have some SOP for how you prepare your sample, some standard sample holder or sample prep tools that you would use. So try to get it as consistent as you can, even though you have people doing it.
Yeah, so even things like a sample press might be useful in that case. Make sure you're getting the right amount of pressure every time.
Exactly.
But just make sure consistency, that's going to be that first step. Then the next part that we talked about was consistent operation, and that has 2 aspects to it. One of them is setting up the instrument, and then the other one is actually running the sample. So if we take a look at the software.
Yeah. So in the software, it's the same software that we use on all of our XRD diffractometers here. So it might look familiar to a lot of our customers. One thing that's a little different on the D6 Autoloader compared to the standard D6 is we have this other tab up here called the Loader tab, which gives us a little graphical user interface for the loader itself. So to make it simple, to initiate a measurement, we can load a sample in here. We already have one in position 1A1, which is right here. So we can select that position, and then on the right side, we can have some pre-made methods. So we'll just start one here called our quality check. And we'll give it a sample ID. We'll just call this sample 3.
Sample ID field, like you could see, it did prompt for Nick to enter it, but you could have it automatically generated off of a time code or
or
other ways.
Based on the user that's collecting the data. Yeah, there's lots of different ways to automatically generate a sample ID or a result file name.
Yeah.
So if I hit OK here, then we can switch over to the loader and we can see it pick up the sample. It will move it over and drop it into the carousel position. And of course, the speeds of all of these motors can be adjusted. So if you have sensitive samples, you can slow things down.
And here we have some very robust mechanisms. I mean, this thing is designed to be loading 24/7, hundreds and hundreds of samples over and over again. So,
right. It's designed to be run all day long.
That's right. So now when that is running, you could actually even load up the next sample. And then what would happen is it would preload that sample so that it's ready when that swing turns around for it to go.
Should we take a look at that in action?
Yeah.
So I have another sample here in position 1A2. And we'll just do the same thing. We'll do a quality check. And we'll call this sample 6. So now we can see it preload the sample in position 1A2. And then when that swing turns around, it'll be ready for the next measurement.
All right. And those things are really important, especially when we talk about automation, because if you're just slamming through samples, sometimes you're not going to do the full scan, right? You might just scan a peak or two.
Right, exactly. And in this case, we have a measurement that's set up for about 1 minute measurement time.
Wow.
So, yeah, looks like our measurement is just about done. And when it finishes, we'll be able to switch over to the autoloader and see it turn that carousel around and load in the next sample.
And that speed is just absolutely phenomenal on the D6, and that comes from a very small measurement circle.
Yeah,
right?
And there's a couple other things that can improve the measurement speed as well. So the system we're looking at here today is a 600 watt system, has a 600 watt generator. There's an option for a 1200 watt generator. And of course, more power means more photons and faster measurements.
Right.
The other way to speed up the measurement times is to upgrade your detector. So on this system, we actually do have the Linksite XCT, which has good enough energy resolution that we don't need that K-beta filter. It electronically discriminates that K-beta energy.
And I would say that's one of those things that's really important if you're looking at solutions. Don't just look at energy ranges. Don't look at the number. You know, somebody could say it's something EV. You know, actually run a scan and make sure that beta is gone. It's more than just energy resolution. It's also about photon sorting and things like that. So
yeah, you improve your signal to noise and signal to background as well.
Yeah. So make sure that, like I said, that you're looking into all aspects of it. Now, another thing that's really remarkable to me is the background level. And granted, our scans here are starting at 20, but when you start even lower, that background stays just absolutely dead flat on this thing.
Yeah. So if you need to do low angle work, one of the great components of the D6 is you have the availability of what's called the motorized air scatter screen, or the MAS. So if you're scanning at low angles and high angles, that motorized air scatter screen will optimize the background for the entire scan range.
And that's all programmed automatically. So in the software even, you can see on the left side where it says air scatter.
So right over here.
You just say automatic.
Yep.
Right? And then based on the angle and the size of the slit, and it even does that dynamically, right? Based on if you have a variable slit.
It does. Yep, all the calculation is done in the software, and it positions that air scatter screen right where it needs to be.
Yeah, and I think that's what makes this even a better an automation solution, is that full hardware automation aspect of it.
Right. Very minimal user intervention here.
So now, since we mentioned the slit, I know sometimes this is kind of a contentious topic. There's kind of two different camps out there. One says, no, you got to use a fixed slit, and other people say, no, the variable slit is better because you get a consistent beam footprint. It's a question of volume of illumination versus footprint of illumination.
Right.
What's your opinion on this, Nick?
Depends on what I'm doing. Traditionally, fixed slits have been around for a long time. Yeah. That's what most people are used to. But nowadays, in the automation environment, oftentimes you can get the same result quicker by using the motorized or variable slit.
So, and that's a nice thing with that motorized or variable slit, is that you just tell it what size the sample is. I want 15 millimeter footprint.
Right. You don't have to worry about beam spill at low angles if you have the right slit size. You just tell it, I have a 10 millimeter footprint or 15 millimeter footprint, and it sets it automatically at any angle.
And in the phaser, we have designed it so that across your entire angular range, you're going to be covered. It's going to give you the same footprint. It's going to give you the right
the slit can actually open wide enough to maintain that beam footprint.
Yeah, and the air scatter position, because it's driven by a motor over a very large range, it also is going to be in the perfect position across that whole range.
Exactly.
All right. So that's kind of the measurement. Now if we get into the results. So
yep. So let's
how does
take a
that
look
end
back
up?
here at the software. So for today, we don't really have any analysis going on. We're just collecting some data. But if we take a look at the results manager, we'll switch it over to our show measured results. Well, we can see some of the previous scans that have been done. So all of these previous measurements are stored on a server on the instrument. Of course, if we did have some analysis being done, we could see the results for the individual scans as well.
All right, and I think that in that other view, we actually have some results there. And you can go in here, you can sort things and that, but we happen to see two results. So this is when we had moved the system over, and our spec is actually pretty tight on this machine, plus or minus 0.01 across the entire angular range.
Yep, the same as our D8 systems.
Yep. So you can see when it first ran, okay, we got a little red X there.
Yeah, we were just slightly out of spec. So over here on the right side, we can see the report, and it looks like the measured or the observed 2 theta position was just a little bit too far off from the expected peak position. So that's why we have these red X's here. So we reran the calibration of the goniometer of the system, and on the second version, you can see we have a green check mark. All of our peak positions are within spec. Yeah,
I mean, I'm looking at even better than spec there. I mean, 0.00 something.
That's right.
For everything. And that's one of the nice things, though, again, about the phaser and that, say, automation environment. When you walk up to it, you can just hit verify and...
Right, exactly. You don't have to question, is the system aligned or is it not? It'll tell you. So we can see it here in the reports and the results manager. But even just looking at the very bottom of the measurement software, you can see we have this green smiley face and it says instrument alignment check OK.
And with that, what you can do is schedule it to even run, say, the corundum.
Right, exactly. So in our system here, we have the corundum in position 1A4, and we can set that up to run daily or weekly, monthly, you know, whatever interval we like.
And then you'll have that assurance. You can look back on it, make sure that you're not having problems with drift, or even use that as, I mean, I guess it's probably not the best drift standard. For drift measurements, say with dequant, do you typically use a corundum?
Yeah, a lot of folks will.
Okay.
But you can use whatever sample you like, again, as long as it's consistent.
Okay. So now I mentioned dequant. So there are, in terms of analysis, we were talking about analysis, there's a few different software packages that typically people are using here, right?
Right, and it all depends on the type of analysis that you need to do.
Okay.
So, for example, our dequant software is really great for calibration curves. So maybe you're quantifying 1 or 2 phases, and you are able to build standards for that. In some cases, you don't need standards, but it's a more simplistic analysis, and that software integrates directly with our measurement software, so the analysis can be triggered directly after the measurement is finished. And again, the results from that analysis would be put into the results manager that we saw just a moment ago.
And that works great with any of the kind of ASTM type standard things, like, for example, respirable silica.
Respirable silica. You can also do retained austenite analysis with that as well. There's a variety of different ASTMs that you can use.
But then if you need to go a little bit more advanced, say we want to have full quantification of all the phases, some microstructure type numbers, things like that, you can do this also.
Exactly, and that's one application for cement is cements are quite complex. You know, they can have 15, 20 different phases, and you can do Rietveld analysis using Topaz to quantify all of those simultaneously. And like you said, not only the weight percents, but also some of the parameters like crystallite size for those phases.
So if you're doing that more standard-based thing, you'd be using dequant, using the Rietveld to get the full picture. That would be in Topaz.
Yep.
All right. And really, you know, that's another really neat thing that you can do with it. We had mentioned AXSCOM before, is we can also start talking about combining this tool with other techniques.
Right, exactly. Well, you mentioned the LIMS system earlier. So yeah, so it is possible to take one sample and send it around to different instruments with AXSCOM and tie in all of the results into a LIMS system, or wherever you want to send it. It's really up to the user where they want to send the results.
Yep, and how you combine them at that point. Some of these new initiatives with AI and such that we had mentioned, I mean, that all depends on getting that consistent data, say from XRD. That's going to give you the picture of your structural information, so phases, things like that. Something like XRF, that's going to give you the elements that are present. So all of that is important information for fully optimizing things. So with that, if you want to know more, by the way, about the D6 phaser, we have a whole series of Live from the Labs that we had done. And we talked about all the different facets of powder diffraction and things like that. So you can always watch those. But now it is time to answer some questions. So we do have some that had come in before. And if you have any other questions, go ahead on the side of your YouTube screen. You can type those in right now and we will get to them and answer them now. Now, if we don't get to your question now, or if you're watching this in the future, you can send them in to live.events@bruker.com and we will get you an answer. So the first question is from Ying. Could you please repeat the name of the software which also connects to LIMS systems?
Yeah, so that is called AXSCOM.
Yep, AXSCOM. So that's the one.
That's what it's called.
Yep, and typically if you're looking at purchasing something like that, it will help you to set it up too. There's some integration and things like that goes with it.
Exactly, and we have an automation team that can help out with things like that.
Yeah, yeah. So the next question that came in before the broadcast is from Linda. Which sample holders can you use with the Autoloader?
Yeah, so we briefly touched on this, but there's two sample sizes that you can use. So the first is the industry standard 51.5 millimeter diameter sample rings. And again, those come in, that's just the outer dimension is 51.5 millimeter. We have a whole variety of those sizes with different sample cavities, depending on the amount of material you have. So all the way up from a couple grams of powder can be put into the largest one, down to maybe a couple milligrams on the something like a low background holder. The second size is the slightly smaller 40 millimeter sample rings. And those ones are used a little more often in heavy industry, something like cement or mining operations.
And whichever size you have, 51.5 or 40, you would just need to order the machine for that particular size.
Right.
So, I know one sample holder that is actually really popular with people who aren't necessarily doing the automatic sample prep, but they're doing manual sample prep, is backloading.
Yes.
So those can get you a lot of consistency. With that, what you're doing is you basically take the ring, take the back off, you fill the powder from behind, and then push the back on. When you flip it over, perfect sample every time.
Yeah, you really minimize sample displacement with those.
Yeah, so that's a really nice one. But one other tip for samples, if you're looking at a variety of things, I mean, this is still a nice machine if you're just doing general diffraction work, you want to put it in and start measurements, is always pick the sample holder that you can fill the cavity.
Right, that's important, because if you underfill the cavity, then the top surface of your powder's not at the right height, and that can shift some peaks around and have some negative impacts on your results.
Yeah, or I've seen people, they take one of our standard holders, which has a decent sized cavity, and they just take the powder and pile it in the middle and then try to flatten only the middle, and you're not going to get good results that way.
Not consistent.
Yeah, just make sure get the appropriate size holder for your sample. So the next question is from Vo, and that is about the detectors. When would you recommend the upgraded detector?
Yeah, so there's a couple scenarios where an upgraded detector would be beneficial. One is if you have a lot of sample fluorescence. So if you're working with copper X-rays, elements like iron, cobalt, manganese, and so on will fluoresce. And the Lynx IXET can filter out all of that fluorescence.
Yeah.
The other scenario is if you're trying to increase the throughput of your instrument. So having that, I mentioned this earlier, having that better energy resolution means we don't need that nickel filter. Because that nickel filter, it's really great at removing the K beta energy, but it also attenuates your K alpha by about 50%, depending on the thickness of your filter. So just by taking that filter out, you get about double the intensity. Yeah, and if you're looking at also looking at the baseline, very small peaks and things like that, you can notice with the metal filters, sometimes you'll see little bumps. And that's right. Those are the filtering edges. The absorption edges, yeah. So, if you're somebody like pharma, you might say, iron, fluorescence, that doesn't matter to me, but the data quality and the speed from not having that filter might. Right. Well, it's not just about the fluorescence or the those little absorption edges. Having that better energy resolution also improves your signal to noise and signal to background. So effectively, it lowers your detection limits and quantification limits. Yeah. Now, though you're just doing standard stuff, you're just looking for a basic machine to do everything, you can go still with our solid state detector, the SSD 160.
XRD-2.
Yeah, it's still a great detector. And it still filters out quite a bit of the fluorescence we've talked about, just not quite as much as the Lynx XET.
Right, right. And in the middle, too, by the way, just to kind of complete the picture, so we've got the 160 that has 160 strips, very nice solid strip detector. Then we have the Lynx XET, which has a long heritage of other Lynx XET detectors. That one also can get rid of some of the fluorescence, has 192 channels.
Yeah, a little bit bigger sensor.
Yep. And then if you go up to the XET, that's where you get that energy discrimination.
Exactly.
So, all right. And then we have a question from Siobhan. We currently use a D8 Endeavor. Would you recommend this instead? Now, I think the key there is instead.
Instead, yeah. So the answer is, with so many things in XRD, is it really depends.
Yeah. Come on, Nick, give us the answer.
So both systems are compatible with a conveyor belt. So if automating via conveyor belt is a must, then you could go either way. Otherwise, the main difference is going to be the number of positions you have to load externally. So the D6 phaser autoloader, we have 5 positions. Whereas with the D8 Endeavor, you have up to 66. Yeah. So if you're not using the conveyor belt, then that is really the question, is what is your throughput? But otherwise, in terms of the measurement, you still have access to, both systems have the motorized primary optic as an option. Both systems have that mass as an option, and the same detectors. So in terms of the actual instrument setup on the inside, they're very similar. It really comes down to maybe the power and the number of positions you need externally to have access to.
Yeah, and it's where it's going to go to, physical size. If you just have room for a phaser, there you go. Or if you want to put it in a cart, push it out by the system itself. I mean, this thing can run on 120 volts for the 600 watt.
Yeah, this is a little more transportable than the D8 Endeavor.
Yeah, and then the D8, that's got the bigger footprint, the bigger sample loader, so sometimes that's the right one. So both good solutions, and that's why
you just have to weigh out the pros and cons of each for your application.
All right, and we do have some questions too that have come in, so keep those coming. From Raphael, can you handle 31 millimeter or 40 millimeter aluminum cups in automation?
So that goes back to a question a minute ago. So we can do the 40 millimeter; those are a standard size. But it's not only the diameter, it's also the thickness too. So, those 40 millimeter rings and even the 51.5, they have a standard thickness of 8.5 millimeters. So as long as your sample holder meets those dimensions, then it shouldn't be an issue.
Yeah, for the 31 millimeter, then you'd have to have an adapter of some sort.
Right.
So you'd have to either get to 40 or you'd have to get to the 51.5.
Right.
But in cases like that, I always say, recommend reach out to us and we can help you out with a solution.
Yeah.
So a lot of automation is having discussions between us and you and figuring out the right thing. So another question from Ying, are you going to give a demo about the automation of analysis using EVA and Topaz, then auto-upload the result to LIMS? Thanks. Not in this episode, but that is a good idea.
For another one.
Yeah.
So maybe at some point we'll do a respirable silica live from the lab or something like that.
Yeah, that would be a great one.
See how that works.
Yeah, especially now that we have the Autoloader, we can just load up the whole set and go, and there you go. Yeah, so Ying, that's a great idea though for a future episode.
Yeah, we'll save that one for another time.
Yep. For Aditi, what about Rietveld refinement software are in XRD Autoloader for crystal system phase identification? So Rietveld refinement software.
Yeah, so that would be our Topaz software. And that is really ideal for a kind of a QA/QC environment where your sample composition is pretty well controlled. Maybe you have a couple little variables here or there. And that's why we keep going back to the cement use case where at different cement plants, a clinker is a clinker. There might be a little different from one place to another, or from one batch to another. Yeah. But the samples are mostly consistent. If you have a complete unknown and you want to automate Rietveld, then that is quite a bit trickier to do.
Right. Yeah, I mean, you can do it. You can set phases so they'll like deactivate under certain thresholds
Right,
and
exactly.
things like that.
Yeah, it takes a little more setting up, we'll say,
Yeah,
to do.
yeah.
And yeah, a little more complex.
Yep, and there is also, depending on the size of your integration, of your automation, we do have software that allows us to access other things like phase identification and things like this through the automation setup. So again, I would just reach out to us and we can discuss some of those customized solutions for everybody. So with that, we actually have come to the end of our questions and also the time. So I'd like to thank Nick for joining us.
It was a pleasure as always.
All right, thanks Karsten for that, Karsten Knorr for that great introduction to the instrument itself. And thanks to all of you for taking your time watching us today and seeing the new Autoloader here in action. So until next time, keep your signal high and your background low.